Yo, what's up, guys? Welcome back. At this point, I don't even know what episode we're at. Episode like 57, I think. Pretty sure. Yeah, 57? No, 58 maybe? 58 maybe, I think. I don't know, could be. Yeah, 58. We did this one yesterday. So yeah, episode 58, welcome. The higher the number gets, the more crazy I think that we even made it this far. So kind of makes me want to keep going every day we get later. So, but yeah, another episode, another day. Let's take a look at this Pokemon sound right here. Looks like we got a Growlithe. I believe, is this the evolution for Ninetales? No, it's not. Okay, I thought it was. This is a pretty cool Pokemon though. That's cool. Anyway, let's listen to the cry. I don't even know how you're meant to even do these sounds. Like, I feel like all the sounds I make are the same. I don't know. It's hard for me to do these sounds, but yeah, that's our Growlithe cry. Let's go. Yeah, let's check out some problems. Length of longest Fibonacci sequence. That sounds like an interesting problem. I actually worked with the Fibonacci sequence yesterday. Did a little bit of Fibonacci with a student. Subsequence derived from another array by deleting any number of elements, including none from array, without changing the order of the remaining elements. Example 358 is subsequence 3, 4, 5, 6, 7, 8. The longest subsequence of Fibonacci like is 1, 2, 3, 5, 8. Okay. Okay, given a strictly increasing array of positive integers forming a sequence, return the length of the longest Fibonacci-like sequence of array. If one does not exist, return 0. Now I'm trying to think how we can approach this problem. To be honest, I really don't know kind of where to start. I know what the Fibonacci sequence is. I know it starts from 0. You 0 plus 1, right? That's 1. 0 plus 1 is 1. 1 plus 2 is 3. 1 plus 3 is 4. 3 plus 4 is 7. 10 plus 4 is 11. 11 plus 7 is 18. Is this how you do it? I don't know, something like this. I did it yesterday, bro. I cannot even remember how to do it. Fibonacci sequence. 0, 1, 1. Oh, we got 2 1s. So 0 plus 1 is 1. And it must be 1. Then that's where I think I went wrong. And it must be 1 plus 1 is 2. 1 plus 2 is 3. 3 plus 2 is 5. And 8. And 13. Yeah, that looks right. Then 21. Yeah. Okay. I mean, maybe we could store all the numbers in a hash map, but constraints 3 to like 1,000. You have to store a lot of numbers in there. I don't know if that's really the right way. I don't think that's the right way to approach this problem. I'm thinking, do we add these numbers and start? I don't know, depending on the length. I don't know. See in discussion. Glad to see an n squared log n approach is accepted. There's no hints or anything. We're gonna have to ask for a hint. So I'm not sure kind of how to think about this problem, to be completely honest. 873, length of longest Fibonacci subsequence. Give me some hints. Oh, okay. Oh. Given a strictly increased array of positive formula series, return the length of the longest Fibonacci-like sequence of array. If one does not exist, return 0. 1 plus 2 is 3. 2 plus 3 is 5. 5 plus 1 plus 2. Okay, so this is the sequence, right? We got 1, 2 is 3. 2, 3 is 5. 3, 5 is 8. Okay. So I thought we... Damn. I thought we had to generate like our own Fibonacci sequence starting from 0, 1, and we count the values that are in the normal Fibonacci sequence. But I didn't realize we have to count from these two. So that makes it a lot different. And again, I should have read the problem. We're given a strictly increasing array of positive integers forming a sequence. Return the length of the longest Fibonacci-like sequence of array. If one does not exist, return 0. Okay, so that makes it a little bit easier. So I think here, how we're going to start this sequence is that, well, I'm thinking we put all these numbers inside of a hash map, right? So we put all these numbers in a hash map. And then we look them up. So we start our Fibonacci sequence from this first and the second element, and then we look them up, right? Because we only really have to return the output. So that's kind of what I'm thinking. We'll start from there. So thanks for that, Blake. So I remember to send me $55. That was very nice of him. Very, very nice. That pays for my service tomorrow. So that's good. I mean Saturday. Okay. Let's figure out this. Okay, so let's create a dictionary. So my dictionary is equal to this. Yeah. Okay, so then we want to loop through each of our values. So for I in nums, I guess we can just, we're going to do it the normal way. For I in nums, let's do underscore dic. Yes, if I in my underscore dic I know there's never going to be a duplicate value, but I'm just going to add it anyway. Like, I dig I plus equal to 1 else minus go dick, because it's, yeah, it's strictly increasing. I mean, I guess we can. Let's just do if I not in my dick. I mean, it's always going to pass. Then let's minus go dick I is equal to 1. Right. Let's print our dictionary just to make sure that we did this here. I get an array. Okay, nice. So now here we want to create, well, first is equal to array 0. Second is equal to array 1. I don't know if this is the right way to do it, but we'll take it. Okay, right. So then, ooh. Okay. Okay, so now we got to simulate the Fibonacci sequence. So how can we do that? Well, we can do, well, how can we do that? For I we can do how can we simulate this? What's the best way to do it? Well, we could do while loop. I'll make this look better. You do a counter. How do you do it? I think it's like counter array or something. Print, just to make the code look a little like less blah. Okay, yeah. Okay. So I guess we have. I guess we can do it for the size of the array, because technically, well. So let's create like a little count here or something. Let's initialize it to the length of our array, right? And we can do, well. Because technically we can't do any more than what's in our array, right? So we could do, well, count is greater than or equal to 0. Then we do, well, we do res equal to 0. God, I need so many variables. First, I guess we can do suppose and is equal to first plus second. Right. Then second is equal to first. I think we're going to do temp variable here. We do our answer here, right? And then we do, well, Then we check, well, if hands in my dictionary is plus or equal to 1, right? Then second, the first is equal to second, and second is equal to ands. Then we keep looping. We return our res. Okay, got an infinite loop. Oh, we're not decrementing count. Loop. Let me just decrement our count. Count minus. Oh, count. Think about Java. Oops. I'm thinking about this wrong, I think. How is it, the first two numbers always included in this Fibonacci sequence? Or was I right before? Do we do 0? 0 plus, I think I got 11 in here though. I think I'm missing something. Ah, it means you have to check all pairs. Okay. Okay, instead of using a counter, we need to use a set, apparently. So let's do hashes equals set. Apparently we don't need this. Trying to think here, well, we want to use all numbers. We want to check all numbers, then we got to do I in range length nums, and then we do a j loop for j in range length nums. We start here at I plus 1, right? equal to 0, then here we create the length variable. We could start with 2 numbers, so our length is equal to 2, right? And then we do because then we're gonna this is confusing. Because we're gonna start from I. Array I. Let's do first is equal to array I. Second is equal to array j. While array I j in hashy. First plus second. Then we have first is equal to first is equal to second. Second first plus second. Second is equal to third. Length plus equal to 1. We want to do the max of, sorry, we want to do max length is equal to max length, max length. And then we want to return max length. Let's see if this runs. Nums is not defined. Array. What are we doing here? We have j. We start without length, which is first and second. Then we check while first plus second and hashy. I don't know. What's wrong here? Pretty confident this is. I'm just gonna have to see. My return statement, dude. No way, bro. Really, bro? I'm inside the for loop here. Bro, I'm tripping balls right now, dude. Okay. Does this submit there? Or is this too slow? No, it doesn't. What do you think of an optimization? Oh, that's a total wrong answer. Oh. There's some sort of condition. If one does not exist, return 0. Positive format sequence, return the length of the longest Fibonacci sequence of array. Sequence is Fibonacci like if n is greater than 3. Okay. So we return max length if max length is greater than or equal to 3, else 0. Let's go. Okay. All right. Well, I feel like not a bad problem. I mean, I just didn't really. Again, I don't really feel like I understand the problem straight away. But your solution is elephant cubed.
Hello everyone, hope you're doing well and welcome back to my channel.
Yes.
Today we are at day 27. This is the second last day for the February daily lead code challenge. We are just one day away from completing this particular month's all the challenges. Okay. And again, today it's a very good question. Like let me like so about how to optimize it further. So today I will be showing you three solutions. Basically, remember all the solutions are accepting and all of the solutions are able to clear all the test cases.
This is what
Still,
we did.
I will show you how I'm getting like say, I will be showing all the logic building steps. How I'm getting the intuition that okay here we can optimize and then I'm optimizing there and then we are like doing it further. Okay, I will be showing you three such
This
steps.
guy speaks
So I
so
will be showing
fast,
three
man.
solutions in total in this video. And yeah, this is a very nice question. I'm sure that the first solution would have already guessed, but yeah, the next two solutions we will just try to build on the intuitions that we have and based on the outcome of this, and then we will be going further. Okay, so it's a very nice question, and after this video, you will be having a very good grasp. You are going to grasp a total like thorough solution for this question, okay? Because now you will be knowing all the operations that could be run in this kind of scenarios, right? Let us quickly begin. See, my expectation is that you would have, see, first of all, this is among the first 1,000 questions of Leetcode, so they are called the golden questions. Let me repeat this thing because this question, deserves that praise, okay? Now, I am assuming that you would have already gone through the question. If you have not, just let me highlight the important points. Then you can pause the video, take the question link from the description, and then see it. Okay, then you
Man,
can
this
come back
guy
to it.
is speaking insanely fast,
That are
bro. Oh
going to be
my
part of our
gosh,
series
dude.
depends on the first two elements. Okay, but let's see how to optimize further. Okay, if I can show you the output, see three. Okay, this is actually a wastage of our computer. Okay, yes, starts from here. Okay, see the
How do you optimize this further? Bro, Jesus. I don't even know. Let's take a look at some solutions though. 2.0 is post dynamic programming. Huh. Seems interesting. Phone breakdown, okay. We need pairs, 2.0 technique helps find pairs sufficient dynamic parameters used to store previously found subsequences. Use the DB table. I was even reading the Python solution. Jesus, dude. It was Java, bro. I'm so used to doing stuff in Java. Let's see.
Comparing these, the
Bro, I swear. Actually, I like my solution. I feel like my solution is the easiest way to think about it, to be honest, but I don't know. Yeah, mine's a brute force solution. This is a lot harder to think about, dude, honestly. Like, at least for me, like reading this is a lot harder to think about. The DP approach, I mean, space complexity of n squared, optimized dynamic program. Never guess it in an interview. Jeez, man, some of these guys, bro. Every day, bro. Like, wow. Like, bro, it makes me look like a little... I suck, bro. Interesting. All right, let's get to another problem. Okay. Take a look at a hash map problem. For some H index. Let's do a repeated DNA sequence. Okay, for the DNA sequence, compose a series of nucleotides abbreviated as A, C, G, and T. What? I'm so confused. One, two, three, four, five. Return all 10-letter long substitute substrings that occur more than once in a DNA molecule. You may return the answer in any order. So what's the best way do you think to approach this problem? 10 letter long things. Now the brute force here would probably be, we take 10 elements, we store it, we take 10 elements, we store it, we take 10 elements, we store it. And we output the actual. What do you think? to solve this problem. We go 10, 10. Maybe we could store everything here inside of a hash set and compare if this is inside of the string. Fuck, man. Try to think about this. How can we approach this problem? Oh man, jeez. We have 2 pointers. I know it's something, I mean, it's a hash map problem, so it's something to do with the hash map, you know, like, obviously, right? Little sliding window. I was thinking about that. Okay, so I think here what we're going to do is we're going to create a hash here, right? We're going to store every single thing we see, right? We're going to create a left pointer, it's equal to 0. We're going to do for right in range length s. If right minus left is equal to, well, it's always going to be 10, and we extract this substring. So we would do, well, how do you slice in Python again? Substring is equal to guess start left, right, right. Then we check, well, we create a res array here, right? And we do, well, if substring in res, sorry, substring in hashy, then substring, sorry, res.append substring, and then we do like res if substring in res. Else we just hashy dot add substring. String substring. We just return our, or we want to increase our left too, so we do left plus equal to 1. We return res. Not sure that worked. What's this edge case here though? Like if the length of s is equal to 10, we just return s, bro? I mean, I don't know. Man, what's the edge case here, bro? I guess no, we could probably just do, well, if string substring in res, and we just continue. That work? Bro. Okay, sweet. I think we need to put this in an else here. Else. How is this not? Ah, man, how is this not? String, substring. Bro, how is this not returning? What am I? What is my bug? Oh, this is exclusive, right, man? If substring and hashy res out append substring else. String, substring, and hashy res out append substring. Bro, what am I getting wrong here? Oh my god, am I doing? Bro, what am I doing? Oh my gosh. Bro, that's why it's not doing anything. How did I do that? That was hashy.add string substring. If res in hashy. We just use a set here. I think that'll fix it. Because you're always going to return no matter the duplicate. Let me just convert this to a list. Cast it to a list, brah. Will this run though? Yes, it does. Okay, so what if we didn't have this here? Would this run? These ones would pass. Okay. 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 Alright. Cool. Let's check out another one. Maybe we can do longest harmonious subsequence, whatever that means. I don't know what that means, to be honest. You'd find a harmonious array as an array where the difference between its maximum value and its minimum value is exactly 1. Given an integer array knobs, return the length of its longest harmonious subsequence among its possible subsequences. As an array where the difference between its maximum value and its minimum value is exactly 1. The difference between its maximum value and its minimum value is exactly 1. Given an integer knowledge, return the length of its longest harmonious subsequence, so on and so on. So we got 1, 3, 2, 5, 2, 2, 3. The longest harmonious subsequence is 3, 2, 2, 2, 3. Okay. 1, 2, 3, 4. Be 2, right? Yeah. No, I feel like this would be the same way that we solved the other problem, no? Like, seems like kind of the same way. I don't know. Well, obviously sliding window would work here too. I mean, would it? I mean, you could sort it first. Right? I mean, you could sort it first, sort this, and then use a sliding window over it, I'm thinking. Because really you're only outputting the length here. So Give me some action value. Exactly one. Let's do the brute force approach, just like so we have a good understanding. Because I think the brute force approach is literally the same as the other question, right? Like, the other one where we were doing the Fibonacci, well, in this one we're just checking, well, if is it the same? Can you solve it like that? I don't know, because we're not looking plus or minus, right? Okay. Oh, man. I'm just gonna sort it. I'm just sort. I think to solve this we use a sliding window and we just right, because then we can loop while we can check from 2 to, well, if then we see 3, then we can go, well, we can move to 2, go 2, 2, 2. Yeah, I don't know. Let's see if that works. Well, we do left is equal to 0, so we would do like a max length. Need our max length here, which is 0. Need our left pointer here, right? If we're right in the range length nums, we would do, well, if nums left okay, we do, well, while nums left plus or equal to, so equal to, while nums left, wait. While nums left plus or equal to, oh my god. How are we gonna do this? Well, how will we check, well, the next number? Like, while nums left. Nums left is next less than nums left plus 1. No, but that loop's never gonna stop. That's so stupid. Like, okay, let's try the brute force approach. For j in range I plus 1, weight nums, and then we check, well, if nums I nums I is equal to equal to nums j, then we increment our counter, count plus or equal to 1. To put our count inside the loop though, right? Equal 1. And we do max length is equal to max, sorry, yeah, max length, count, and we return our max length. Wait, well, nums I plus 1. We have to make sure it's in range, right? So, and nums bro, how is this out of range? Nums I don't even think we can increment like that, to be honest. Oh shit, they don't have to be next to each other. Oh shit, okay. Mm. You don't need a while loop then. You can just do it using if statements if then we increment count plus equal 1. We can check well else if thumbs I plus 1 does not equal thumbs j and we can just continue, otherwise we return the max length. Oh shit, we're not checking updating the max. Max length is equal to max max length count. I'm not sure. Guess we don't want to count from 1 inside this loop here. Why? Yeah, I don't know. What is wrong here? Oh my gosh, dude. No, we want to loop it over each generation. take a look. Let's run this. Oh my god, dude. Dude, I don't know why this is wrong, bro. I have no freaking idea why this is wrong. Right now, you're counting the only once when you've... Bro, what is this telling me, bro? Like, I'm literally doing that, dude. Bro, this is so stupid. I'm just gonna copy this. I don't understand what I'm doing wrong here. Wow. Okay. I generally don't know why this is not working. Okay. I don't know why this is not working. We're looping over I. We're starting at I, and we're going to loop through each number, right? For j and I plus 1. If I plus 1 is equal to nums j, so if it's within the range of 1, because we're sorted, we're going to count. Else if nums I plus 1 is less than nums j, we're just going to continue. I don't understand how this returns 1 here. How does... Are we missing anything here, bro? Like... For the maximum? The difference between... Max length if max length is less than 0. Max length is 0. Why is this 4, 1, 3, 2, 2? Dude, this problem is like tripping balls for me, dude. Like, what the hell? This is crazy, dude. Fine, range nums. Chain range, I lost one leg. Let me write this better. If nums j is greater than nums I plus 1. Let's just break from that loop, okay? We want to skip this iteration, right? I want to debug this print nums I. Bro. Two. Bro, what? I understand. Okay, so we're looking here for 2, 2, 2, 3. I guess we need some sort of like what if we had if, not if here, we do if nums I minus 1 equal to nums j, and we can do count is equal to 1. Yeah, I knew this wasn't gonna run. Why did I click submit by accident? Can we do 3 separate if statements? What we do like. If here and then do an if. Oh, that's not gonna work. Bro, this is pissing me off, dude. Jesus. Um. I don't even know. This seems like such an easy question as well, bro. Like, it's actually kind of frustrating me a little bit. Like, yeah, bro, this question's kind of annoying me a little bit. I'm not gonna lie, but find a harmonics array as an array where the difference between its maximum value and its minimum value is exactly 1. I think I'm just confused with this problem. Like, I'm kind of thinking my thought process is that we're going to start at 3 and we're going to look for 2, or we're going to look for 4. You know, in this case here, we have 2 here, so we got point of the problem and count the occurrences of each number in the array. Then calculate the maximum sum between occurrences of n plus 1, and minus 1. Okay. Alright, well, let's just do that then. Let's create a hash, a dictionary. Equal to count of nums. Alright. Okay, so now we do, well, for key and value in my dictionary. If key plus 1 my dictionary dot items. And this is what we do. Well, if key can you reference key like that in dictionary? I don't even know. I don't think so. I don't know, dude. If I have a hash map and numbers. If key plus one and free. And key plus one and key plus one. This length is equal to max key max to max length count. Let me return my dictionary. I'm not returning my dictionary, bro. Dude. Return max length. Bro, what? No. No way this is the solution, bro. Bro. Are you fucking serious, man? Bro, how did I not think about that? I can't believe I just did it that easily. I thought about it like that with a dictionary. Like, bro. Interesting problem. All right, we're gonna do one hash map problem because I want to do a binary tree problem, and then we're gonna call it. Said I was gonna do a binary tree. I was gonna rage quit for a bit, but I kind of want to do a binary tree problem. Let's check out this one. The manager knows that no duplicates. A maximum binary tree can be built recursively from nums using the following algorithm. Recursively. Okay. Create a root node whose value is the maximum value in nums. Recursively build the left subtree. Recursively build the left subtree on the subarray prefix to the left of the maximum value. Recursively build the right subtree from nums. Oh, okay, so we're building. Wait. I'm confused here. To the left of the maximum value. But what a weird problem. Like, kind of confused with this problem a little bit. Ah, okay, okay. Okay, so we get 6. Okay. I think this is a tough problem with an 85% acceptance rate. I think this is pretty tough. Like, how can you solve this problem? We put recursively from nums. Create a root node. I guess we'd have node, right? And the first value we'd pass in would be technically, well, recursion. Turn dummy. Recursion node, we do, well, we'd have to think about this. How are we gonna do the left subtree? Recursively build the left subtree on the subarray prefix to the left to the maximum value. I think I'm gonna need some more hints, bro. We can give to 654. Do we need to recursively do this? Like, I mean, we don't need to, of course, but. Yeah, I'm finding it difficult to code this. I'm not really too sure. Call a helper function. Yeah, man, this is a tough problem, bro. I don't think I'm ready for a problem like this. We're gonna skip this problem. That's a tough problem for me to think about in terms of the recursion here. Like, I feel like if I just look up a solution like that, I'm not ready for a problem like that. So. I really. Give me the root of the binary tree. Did that? Okay, I've looked at this one. I just don't remember. Return the smallest subtree such that it contains all the deepest nodes in the original tree. Largest depth possible among any node in the entire tree. Maybe BFS is maybe the move here. Is BFS the move here though? Import corrections. How to import EQ in Python. I'm gonna do BST. I'm gonna do BFS for this one. Q is equal to DQ. We pass in our root node. On Q, Q. I in range. Length is equal to the length of the Q in range length. We want to initialize the level as well. Level is 1. Q.pop. Q.pop and if let's do this, we do well if node how do you add things into it? Again, I always forget append. Pop left. Check if loop node, right? It's called the deepest if it has the largest depth. Well, I think technically we're only looking for. I think technically we're only looking for one. node. Not node dot left and not node dot right. And it's a leaf node. Is this a breadth first search problem though? I don't know. 865 small subtree with all the deepest nodes is the best way to approach. This is a tough problem as well, bro. Oh my god. Why is it like... I don't think I did this one. Yeah, no, I didn't. I think we did look at this over in a video. Okay, let's... dev BFS. Node and next step. Alright, you put all this in there. There's no way I can solve this problem on my own. Like, zero chance. Like zero chance I'm solving this problem on my own, bro. Like, I'm curious, bro. I'm gonna look at the submissions because, bro, this is like tough problem, dude. Like, that's if not root return. Man, bro. These problems are tough, bro. Problems are really tough, dude. Oh, bro. This Leetcode. Let's do this one. Given the root of the binary tree, return the level order traversal of its nodes, i.e. from left to right, level by level. Okay, we're returning a list of a list. Let's do this problem, because this is a BFS problem. It's way easier, bro. Oh my gosh, dude. Jeez, I gotta go in a second, dude. From collections, import EQ. We do well. How do we do this? Q is equal to DQ. Q passing the root, right? Small Q. Get the length of the Q, right? Do for Q, one Q for I in range length, and we do well. Node is go to DQ dot top left. We need like a res already here, right? We do well. Is this the correct way of implementing it? I mean, right? Because if we have a queue, no, yeah, we have our queue here. So we have these two lining up. This one comes out. This one lining up. This one adds, the other one's boom, boom. This one goes out, adds his children, boom, boom, boom. Comes out, adds his children, boom, boom. Okay, yeah. I think that is correct, yeah, okay. DQ.pop left. We add this node. We do like cur.add node.val, then we check children, and we do, well, if node.left, then we append q.append node.left, if node.right, q.append node.right. Cur.append, sorry, res.append cur, then we return res, right? This is definitely incorrect for sure, but oh shit, length of the queue. Oh shit, dude, I need this after. Fuck. Treated object is not iterable, dude. What the? Okay, there we go. Node is equal to, oh my god, DQ, this is like the Q. Q.pop left, then we add, oh sorry, cur.append node.val. Okay, we check the children. Yeah, we append res and we return res. I was right. Tree node is not iterable. We need to add Let's see. Attribute val. If not root, return. Sorry, I need my. What did I do wrong? 920. We need to append them together. Why? I would have thought these would append together. Bro, why isn't this appending like this, bro? Like, bro, I'm so confused right now. What's my bug, dude? Tell me. Oh my god, dude. Is that why? Jesus, dude. Bro, no way. That was my issue, bro. Oh my god. Really, bro? Okay. You did it recursively. If not root, return root levels. If length levels equal levels up. Alright, well, we'll look at that later. Yeah. I'm happy I got that BFS approach, so that was good. Well, yeah, we've been going a little while. Appreciate you guys watching. I'll see you tomorrow.